So finding domain, we have a decision tree. First question we asked, does the function have an even root? If yes, we take what's inside the radical, set it greater than or equal to 0, and solve for x. Whatever that happens to be is the domain. If we said no, then we ask a second question, does the function have x in the denominator? If yes, we take the denominator, set it equal to 0, and solve for x. Whatever x happens to be to make the denominator 0 gets excluded from the domain. If it's no to both questions, the domain is all real numbers because everything works. Try a few examples. Y equals 4th root of x plus 3. Is that an even root? Yes, so that comes over to here. We take x plus 3, set it greater than or equal to 0, solve, so subtract 3 from both sides. We get x has to be greater than or equal to negative 3. That would be the domain. B, does it have an even root? No. Does it have x in the denominator? Yes. So we come over to the middle part. We take that x plus 4, set it equal to 0. We solve. X equals negative 4 makes the denominator 0, so our domain is x cannot be negative 4. On C, f of x equals x squared plus 4x plus 4. Does it have an even root? No. Does it have x in the denominator? No. So its domain is all real numbers. So here we've got some examples to figure out the domains. Start with the first one, y equals cube root of 8 minus 3x. Even root or odd root? It's an odd root, so give me your answer. B, y equals square root of 7x minus 4. Square root's an even root, so we take 7x minus 4, set it greater than or equal to 0, solve. You tell me the domain. On the third one, we've got like a real-world example. Soccer ball is kicked from one side of the field, and its distance to the other side is modeled by the equation y equals 16 times the square root of negative 1 times the quantity x minus 60, all of that minus 4. What domain makes the most sense for the situation? Then we've got a picture of the graph over here. Well, first off, is it an even root? Yes. So we take that negative 1 times x minus 60, set it greater than or equal to 0. Start solving, divide by a negative 1 on both sides. That gives us x minus 60 on the left, but when we divide by a negative, we have to flip the inequality symbol, so it has to be less than or equal to 0 now. Add 60, and so x has to be less than or equal to 60. But then we kind of look at the picture. That makes sense with how far to the right it can go, but how far left? Well, can we have a negative distance? No, so what makes most sense is from 0 to 60. Now the other type is working with vertical asymptotes and any points of discontinuities or holes. So one of the first things that we do on this, we factor the numerator and denominator. So the one on the left, pull out an 8x, and that leaves us with x minus 1, and then x squared plus 6x minus 7 factors into x minus 1 times x plus 7. On the right, the top doesn't factor, but the bottom becomes x minus 3 times x plus 3. Second step, we cancel any common factors. On the left, we've got common factors, and we get down to just y equals 8x over x plus 7. On the right, nothing cancels, so we just copy it down. Whatever makes the denominator 0 at this point in the reduced fraction is going to be a vertical asymptote. So on the left, we take x plus 7, set it equal to 0. And so we've got a vertical asymptote at x equals negative 7. On the right, we set x minus 3 equal to 0 and x plus 3 equal to 0. So it has vertical asymptotes at 3 and negative 3. For figuring out the whole, we take the canceled factor, what makes it 0, gets us the x value of our whole. Plugging that x value into the reduced fraction gets us the y value of that point of discontinuity or the whole. So on the first one, x minus 1 is the factor that cancels, so what makes that 0 is 1. So the x value of our whole is at 1. We plug that into 8x over x plus 7. That gives us 8 times 1 is 8, 1 plus 7 is 8, 8 over 8 is 1. So our whole is at 1, 1, our point of discontinuity. The one on the right doesn't have a whole because nothing factored, nothing canceled from the factors. Okay. Now I'd like you to try that with A and B here. C we'll kind of walk through. So take a look. It's already been factored. What cancels is x minus 1, so we're left with x plus 2 over x plus 6. The vertical asymptote, I'm going to take x plus 6, set it equal to 0. So that's going to have a vertical asymptote at x equals negative 6. The factor that canceled was x minus 1, so the whole, the x value will be whatever x makes x minus 1 0, which is 1. Plug that into x plus 2 over x plus 6, and we end up with 3 over 7. Can't simplify that, so our whole is at the point 1 and 3/7. Check the other answers with me, try the diagnostic, and go from there.